so long. I don't even know if
So
I remember how
basically,
to
it's
use
just
since Thursday. That was a long time. I want to see. Nobody ever takes my spot, and I stand in the corner.
oh, that's too good.
Yeah, we're in big.
Okay.
Oh, I thought it said mobile dessert. He's like, your dessert has to move?
Like, that's weird.
So, did you guys finish your worksheet? Other than part D?
Yep.
Yes? So that's what we need to talk about. Right. Okay, do you have your calculators?
Really?
Because I think it's going to be helpful to graph them in order to do those parts. So if you would, on your calculator, for number 2, graph that function, the position function, negative p to the third plus 7t minus 14t plus 8.
Lead.
You got it?
No.
No?
Still trying to figure out my calculator. I'm confused. What am I doing?
Okay, hold on just a second.
Okay, wait. I have to put in this version.
Just raise it to the third. That's squared. This thing. And then press 3. Do we have to change the window or anything?
You might want to change the window. If you look at the graph, it looks like it makes sense for the x values to go from 0 to 5. Do you know how to do that?
Like this?
That's your graph, good. If you go to window, you can, if you just go to window and change your x values to be from 0 to 5, you'll get a little bit closer up view.
I don't know what's going on.
Sorry, Skylar.
Do I change the Y's or?
No, you can leave the y's.
Oh my god. Why can't I just delete? I hate calculators. They're stupid.
What's going on?
I can't get it like to delete that one.
Here. Okay. That's all like down here in this entry line or whatever. And then if you go, it still says F2 max. Where it says F1 max. I just delete it and still not do it. Delete. Now try to type it on there.
I did type it in there though.
Oh, you did?
Yeah.
That didn't work.
What are you doing? Are you showing my struggle?
Yeah.
Okay.
Thanks.
So remember that's the position. And we're going to say where it starts, in what direction it's moving, and when it, well, it's not going to stop, but when it changes direction, basically. And if you can't get it on your graph, you can get mine.
And do I just press enter? Like, that's what I did last time. And then it just maybe it did. Maybe, I don't know.
Well, problem is all of that ends up to be in the exponent. Just look up of Olivia's for right now. We'll figure it out for the next one.
I wish I could just delete everything. Oh.
I'm sure that calculator is very handy if you know how to use it properly, but I don't.
I'm sure it's not.
Alright, so this, can you guys see that? No. Yes? Okay. So this is what the graph looks like, and we're talking about, what does it say? Describe the motion of the particle. When does it change directions? Okay. So this means this is the time axis, and this is the position, which we call x. So at time 0, what is the position? And we may have already
Deleted
found,
everything.
we may have already found that to begin with, but what is the position when the time is 0? Can you tell?
How are we supposed to know what the y is?
Well, if you can't tell by looking at the graph, you could go to second table and do it that way and see when x is 0 what the y value is. If you can't tell by looking at the graph.
Eight.
Okay. So we're going to say the particle starts at the point s equals 8 and moves, what direction is it moving if it's going down?
Wait, what?
If it's moving in the negative direction and it's going along the line, would that be going to the right or going to the left?
Left.
Right, so it's moving left until it stops. And I think we already figured that out. In part C, we figured out when the particle is at rest. When did we decide it was at rest?
3.21 or 1.425?
Okay, so what would be the first point then?
1.45.
Right, so it stops when t equals 1.451. And if you guys remember how to find the minimum on your calculator, if you go to second calc and go down to number 3 where it says minimum and hit enter, and then you scroll over to the left part of the first curve, hit enter, and then the right hand part of the first curve, and hit enter, and then hit enter again. It should give you the y value at that point.
You could have 0.63.
Good?
Yes.
Usually if you hit the over arrow, it will go back down. Okay, and then, so then what happens after that when it hits that minimum?
Starts to go back up.
Which means it's moving in what direction?
Mine's like pretty close up now, right?
If it was moving left when it was sloping down, what direction is it moving when it's sloping up?
How does it move? Like, I get that left is negative, but in the picture, how's it moving left if it's all on the right side of the...
Because the right-hand side is the time. The x-axis in this case is time.
I finally got it to work, but I don't know how to like get it so that I can actually see the entire thing. 'Cause I don't know how to make
It's
this
not,
go
like, this axis is representing as the time goes on, this is representing the position. So if the slope of the position is negative, then it's moving to the left. And if it's positive, it's moving to the right, because remember slope is velocity, and if velocity is negative, that tells the direction of the velocity.
So I got it. I don't know how to make it.
Menu. If we're on the graph, maybe. If we scroll over to the graph part, menu,
Calculator's so convenient. See,
window.
Mama bought two. She bought that one and that one. And then before I could grab that one, Spence already did.
This one's actually technically the better one.
I know, but that one's easier to use.
It's easier because I know how to use it and I could help you, but
Because like everyone has that calculator.
Right.
No one has this one.
no.
Like Mr. Fly had a hard time figuring this one out. I was like,
Yeah, so maybe we should just hide the table for now.
That's what I was
It's
trying to
not-
get away. I was like, the table will go.
The clock's loud.
It is really loud. And mouse
I wanted to like zoom out. It's like, it like shows like that.
There you go. I'll show you how I did that earlier. Okay. So then it moves right until it stops again when we already figured that out. T equals what? When we figured out the 2 points where the particle was at rest in part C.
3.2.
3.21 and S equals, so you can do the same thing and calculate the maximum at that point on your, using your graph on your calculator. If you go back to calc, maximum, and then do the left side of that part of the curve, and the right hand side of that part of the curve. And then guess, what do you get for the y value when x is 3.21?
Do we have to do left bound of the second curve now?
Mm-hmm.
Did you say X or Y?
Y.
2.1?
Yes. If you go to menu and maybe turn this graph. Yeah, that's how you can find the maximum and minimum. Lower bound, you just click somewhere on, so if you're looking at the maximum here, you just click somewhere on the left hand part on the new one, so that's good. And click. And then the other side of it. And click. And you click.
I did.
Maybe it's just it's showing you right there. Yeah, 3.22 and then 2.11. That's the maximum point. Okay, so that's what you're supposed to do for part D on those. So do you think you can? And then okay, so then it stops at that point, and then after that it continues. The slope is negative, so it's continuing left from there on, and it doesn't stop. It just goes forever. Okay, so see if you can do that for numbers 3 and 4, and then if you have questions I can answer them, and I'll try to help you with your calculator.
So, is the only way to figure these out by using the graph?
Well, you already figured out the minimum and maximum points, so if you can visualize if it's going, and you know it starts at 8, so you could substitute in those values into the function. So like you found the 2 points where it stops, you could substitute those t values into the original functions to figure out the s values at that point, and then know if it's going down or going up to get to them, to know if it's moving left or right. You could do it that way as well. You know what I'm saying? Not really. Do you want me to show you? Without the calculator?
I don't
Well, it's up to you guys.
I don't know if I can do it with or without the calculator, so.
You don't think you can do it with or without, did you say? Alright, so we found in part C that, well, first of all, you wanna know where it starts. So to figure out where it starts without using a calculator, you would substitute 0 for t and solve for s. So using this function, we would do s of 0 equals negative 0 cubed plus 7 times 0 minus 14 times 0 plus 8, which would give us 8. So it starts at 8. And then to figure out where it stops and changes direction, that's where that is going to be where the derivative equals 0. So s prime of t, or in other words v of t, the velocity, equals 0, which we have already done in part C when we found where the particle is at rest, right? So, and then substitute those values for t in the original function. So s of 1.451 to figure out what that is going to be, which we already did on a calculator to find out it was going to be negative 0.631. And then the other point was 3.215. Which we found out was 2.113. And then you can kind of draw a rough sketch to figure out if it's increasing or decreasing, or just think about the y value. So the y values went from 8 to negative 0.631 to 2.113. So to go from 8 to negative 0.631, is it going up or down?
Up, down.
Down. So meaning it's moving left. And to go from negative 0.631 to 2.113, it's going up. And then, if you're not looking at the graph, to figure out where it's going after that, you might have to substitute in another random value after that. So if that was at 3.215, you could plug in a 5 just to see if it's going up or down from there. But we know that it's, oops, I wrote up instead of right. So that's right, and then it's going back left. And you can sort of do it that way without using your calculator.
That was really confusing.
That's why I wanted to show you using your calculator.
I think I missed some of the things because I was trying to figure out how to use my calculator.
Well, that's why I want to work out some of these with the other two. I'll sit by you while you do them so that you can.
Because I figured out where it starts from, like, the first just setting it to 0.
Right.
so I figure out where it starts.
Well, did you graph it in your calculator?
Yeah, I got it.
This is number 3 in your
Yeah.
calculator? Okay. And then you can find the minimum and maximum. So you hit menu, and then analyze graph. And then you have to do both, so it doesn't matter which one you do first. So if you're doing this part, then just click on that.
And then go to God. No, far.
Like over the curve, so that it's on the other side of the curve. That's actually going to be a maximum amount of curve stuff right there.
Do I need to change the window?
Because that was actually a maximum. That's the minimum point of the angle that you highlighted. But
Do I need to change the window?
I'm gonna look at it to see if it does anything. No, but it doesn't. So no, it's fine.
Okay.
I mean, if you wanted to see where it started, you would have to, but you can look at that on the table too. So that was my fault. If you're doing this is actually maximum because it's the highest point of that area, not the lowest point. So that would be maximum 3. Which is 2, 0.
So
Was
that's
2 one of your, when you found out where it was
Yeah.
at rest? Okay, good.
so 2,
So
0
0.
is what?
So 0 is where it's changing direction. And from the starting point to that point, it's going, the line is sloping up, which means it's moving to the right. And then it starts going down, so then it starts moving left, and then you want to see what the minimum is at that point. So I'll let you do that, but I got it on minimum now, so you want the minimum off of this.
Here.
And then
3.33 and negative 1.9.
so was 3.33 another one of your at-rest points?
Oh,
Yeah, 10/3, so yeah, that's right. So it's negative 1.19 stops.
Stops.
And then changes to be going right again. Actually, it doesn't change